Again, welcome to Python programming language. In these lectures, we're going to discuss about Python loops. In our previous lectures, we covered the while loop. In this section, we are going to cover the for loop. So our main objective is to use the for loop to implement a counter control loops. As we said in the previous lectures, a counter control loops means we know how many times the loop will execute. So for loop is always a counter control loop. We have to know how many times the loop will execute. But with while loop, we can implement it as a counter control loop, which means we know how many times the loop will execute. Or we can also implement it using the sentinel value, which means we don't know how many times the loop will execute. But when we enter the sentinel value, the loop will stop. So our condition will be while I is not equal to the sentinel value. Let's say the sentinel value is -1. So we can say while I is not equal to -1, we will keep doing something over and over again. But anytime the user enter -1, the condition becomes false, the loop will stop. We cannot use that concept in for loop. For loop is only implement as a counter control loop. We cannot use a sentinel value to stop it. We're also going to learn how to use the nested loops, which is a loop inside another loop. Also, we are going to learn how we can use loops to implement the following programs, examples. For example, how to find a prime number, how to implement the multi-color simulation, which is based on probability concepts. Also, feature tuition. And also, we're going to learn how to use the break and continue keywords in any loop. It can be while loop or for loop. A break means if the condition is true, normally we write a break, we check a condition. If the condition is true and we have a break, it means we are coming out of the loop will stop. Now, continue means if the condition is true, we are going to skip that execution, then we continue with the rest of the execution. So let's start here. We start with the for loop, but before that, we have the syntax again for while loop. So in while loop, we have our counter variable to be I. We initialize it either to 0 or 1 or any value we want to initialize it to. Then we have the syntax for the while I is less than the end value. The loop body will execute. Then we increment the I variable by 1. So this is a counter control loop. The loop will execute. If we initialize it to 0, I to 0, and let's say we have 10 here, that means the loop will execute 10 times from 0 to 9. If we initialize it to 1 and our end value is 10, it means the loop will execute 9 times. Now the same thing applies to the for loop here. We have the counter variable again. And here we are saying that this loop should start from 0, let's say to 10 again. So initial value will be the beginning of the I value. And the end value will be when the I value will end the loop. So we don't have any condition here. What we have, we use the range function, and we're going to say that the loop should execute from 0 to 10, which means to execute as we specified. Then we have the loop body. So for loop here and the while loop, they are the same. And both at the moment is a counter control loop. So let's see an example here. And this is also Python have a function named range, or we say a method. And if we have a range with a, b, it means, let's say from 1 to 5, it means we are going to do something from 1 to 4. And also, we may have a third variable which will tell us how many steps we have to take. So if I have 4 to 10 and 1, it means I'll go from 4, 5, 6, 7, 8, 9. Now, if I have 4 to 10 and 2, it means I'll go again. If I start from 1, 3, 5, 7. And we will discuss that. For now, we should know that the range here is 4 to 8, which means if we execute this for loop, it will print the content of V 4 times from 4 to 7. So this will be our output 4, 5, 6, 7, because V is a counter variable. And we say for V in a range from 4 to 8, every run we are going to print V. So we start from 4. V is 4, automatically increment by 1, 5, then 6, then 7. We normally don't print the end value. Let's see another example again. Here now we say only range B, but remember here we didn't say A to B. A to B is more better in the sense that we are going to start from a particular value A. For example, the previous example we say 4 to 8, so we start from 4. We are not going to start from 1 or 2, some from 4. But anytime we say for I in a range 4, it means we are starting from 0. So this will print from 0 to 3. So we can see the output 0, 2, 3, and 4. And again, what we are doing here is to print the counter variable each run of the loop. So if we have range 10, it means from 0 to 9. But if I have range 5 and then 10, it means from 5 to 9. So let's say the previous example I'm trying to explain here, we can have a range with 3 arguments. The range method with 3 arguments. So A will be the beginning, B will be the end value. The step will be how many steps we are going to take. So for example, we say for V in range 3, 9, and 2, we should print V, which means we start from 3. So first we are going to print 3, but the step is 2. So we are not going to print 4, we move straight to 5. Then after we print 5, the next will be 7. Now after we print 7, the next will be 9, but we can't print 9. So we end at 7. And we also can print 8 because it's 2 steps. So we can see our output here, we have 3, 5, 7. Because the steps are each run, we had 2. Now, if we have only 3 and 9 and we didn't specify the step, then as we saw in the previous example, by default, the steps are 1. So if we want to increase by 1, we don't need to put the step value, the third argument. Other than that, we have to. We can have from, let's say, 0 to 100, step 5, which means we print from 0, next we print 5, next we print 10, 15, etc. So sometimes previously we say we don't have to do 1 because positive 1 means we are increment. Apart from that, if I want to decrement, then I have to use the negative value. So, and also I have to make sure the beginning value should always be greater than the end value because we are decreasing. Something like we are starting from 5 all the way down. So since 1 is the last value, we don't normally reach the 1. We are going to end at 2. So we start, the beginning value is 5, so we start with 5. We decrement by 1 because we have negative 1. If it's negative 2, then we decrement by 2. Now, if we decrement by 1, the next value will be 4. We print 4. Next round, we decrement by 1 again from negative 4 to positive 4 to 3. Then when we reach 3, 3 minus 1 is 2. When we reach 2, 2 minus 1 is 1, but the end value is 1, so we can't print to 1. So it will print up to positive 2. The first value will be 5. 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2, which will print. But 2 minus 1 will be 1, and the end value is 1, so we can't print it. So the output will be 5, 4, 3, and 2. So next we move to the nested loop. And the nested loop here, we are going to see one program. The program here said we should write a program that uses a nested for loop or a while loop to implement a multiplication table. So a multiplication table normally will be 2 by 2. And we have intersection of column and row. If intersection of column 2 and row 3, it will be 3 times 2, which is 6. This is a multiplication to intersection of any column and row. We multiply and that will give us the answer. So in this case, we have to have two loops, one for the row values and the second one for the column values. So let's see how this code works. So first we start this code by printing our heading. This is a multiplication table. Then we are going to display the name title. So here we say print, empty space, then the n equal to space, single character. Now we say we have our first for loop. We say for j in range 1 to 10. For j in range 1 to 10, we are going to print empty string and then j counter, n will be also empty character. Then we jump to the new line. So we are going to print the new line. New line basically means a new space, a line space. Because we just, for example, if I write the print 10 times, it means I'm going to have 10 empty space rows in my output. So here we just print only once. We have the print method printing nothing. So we jump to a new line. In the new line, we are going to print the dashes. So basically, this will be the heading for the multiplication table. Now, this is where most of the work will take place. We say for I in range 1 to 10, we are going to print first, again, this is the for loop. So one thing we should know that in a nested for loop, when the first value is true, we enter the second loop. And the second loop, we have to do everything until it becomes false. Then we go back to the first loop. So when the inner for loop is not false, we cannot return to the outer for loop. So first, we say for I equal to range, and we print our I1, and we have the end line. Now, we say for j, also range from 1 to 10. So here we're going to display the product and align it properly. Here we have for D, which means again, for space. We use the format function. Again, we discussed about this format function to format our output. And in this case, we are going to multiply. When we start with I equal to 1, we are going to multiply 1 by j when it's 1. Then we have a space times 2, 1 times 2, 1 times 3, up to 10, 9. Now, when we reach the end of the j for loop, we go back again because we haven't finished. Then we go to 2. Then we multiply 2 throughout. When we finish from range 1 to 10, we go back to I again, 3, 4, until we finish with I. Now, when we finish with I, we will come out of the for loop. So this means, again, we are going to have the I will be our row, and j will be the columns. So the first row, we're going to get 10. Then we're going to print the item. Each round we print. So the for loop, we can see that this is what the for loop is doing. It's going to multiply the I. When the I is 1, j is 1, j is 2, j is 3, j up to 9. Then we end. When we reach the end, we go back to I is 2, so now it's 2 times j is 1, j is 2, or 2. Then when we finish, we just print a new line. So first, let's see how this and the animation work. Hopefully that can make us understand this code more. So first, when I execute, the print statement here execute first. We can see the space between, and we can see here. Then I click next. Then you can see here, all the line code from 3 to 7 will give us the dashes, because, and also it's 10 times. So we say for j in the range 1 to 10, we're going to print empty space j, then we end it. Then we print empty line. So we have empty line, then we print the dashes. So this print j here will print the values for us. Actually, that's the values here from 1 to 9 because the range is from 1 to 10. And 1 to 10, when it's 1, we print the j, the counter j, we print it. Before we print it, we have empty space. Then we print it. And when we print, we end it with no value. We just end it with a space also. So the for loop here will execute 10 times. 9 times from 1 to 9. And after we finish, we come out of the loop. We jump a new line. Then we print the dashes. So we can see the indentation with the last two prints here, line 6 and 7. It's the same with 4. So which means those two print line 6 and 7 doesn't have anything to do with the for loop. The for loop is the first print statement. And this will print j from 1 to 9. And anytime you print, it will print empty space. So we have empty space before 1, empty space before 2. We keep going. Now let's see where the multiplication will take place now. So next, we have a for loop from 1 to 10. This is the outer for loop. Now, when we get into the outer for loop, the first I will be 1. So we have 1. We are starting from 1. Then, if we have 1, we print the 1. It's right here. Now, we go inside the j loop. When it's 1, we have from 1 to 9, the inner loop 1 to 9. And what we are doing in the inner loop, we are multiply I by j. The format function here is to format the values by 4 spaces. So the first answer here will be the same because it will be the I is 1, 1 times 1, 1 times 2, 1 times 3, up to 1 times 9. But see what will happen in the next round. When we move back to the outer loop, as we said earlier, when we are in the outer loop, when the condition is true, we go to the inner loop. The inner loop, we are going to execute the statement as many times as possible as far as it's true. When you reach the end, which means we can't go more than 9, then we come back to the outer loop. And this time, outer loop now will be 2. So if outer loop is 2 and we get into the inner loop, what are we doing? We multiply 2 by 1, 2 by 2, 2 by 3 up to. So that's why if we look here, we have 2, 4, 6, 8, 9 up to 18. Then the same thing, we finish 9, then we go back to the outer loop again. And this will keep going 3. So what will happen will be 3 times 1, 3 times 2, up to 3 times 9, which will be 27, the last value. And it will keep going. Again, I'm not going to repeat the 4. Same thing with the 5. And also same thing with the 6. The 6 times 9, so the last value will be 45 now. And that's when we do 5. When we do 6, it will be 54. Last value is 54. First value will be 6. 6 times 1 is 6. 6 times 2 is 12. When it's 7, the same thing, 7 times 1 up to 9. So again, I just wanted to finish the execution. By mistake, I click on the previous button, which will take us back to start all over from 1. So now we are 7. I want to get to 8 soon. And the last is 9. Let's look at the 9 answer. So we can see that to be the last value will be 81. Because 9 times 1 is 9. Times 2, 18, 27, all the way to 81. Now this will be the end of the execution, because when we go back, we increment the I by 1, we get 10. We cannot execute 10 no more. So you can see that the program is finished. So the whole concept here again is when you are using a nested loop, remember that the first for loop, in this case our first loop, we check condition. If condition is false, we cannot go to the inner loop. So the outer loop is true, we go to the inner loop. In order to come back from the inner loop and go to the outer loop again, the inner loop have to be false. So which means we have to go from range 1 to 9. When we reach range 10 is false. Then we come back to outer loop. When outer loop is true, we go back to inner loop until it's false. Now, when the outer loop becomes false, we cannot go to the inner loop no more. So the loop stop. So again, that's the whole concept. Okay, so here we are talking about minimizing the numerical errors. What we are going to say here is that, I think we mentioned this also when we are doing the while loop, is that in a loop, it's good to use a whole number. We shouldn't use a decimal number because sometimes the precisions may change. This program works, but it's very risky. There's a chance we may make an error because of the precisions. So this is a program that, again, will find the sum. We have the condition here. Say example that will sum a series of numbers that start from 0.01 and end at 1.0. So let's see this program. So we start adding from 0.01 to 1. Again, it may give us the right answer, but the chance of making an error because of decimal places is very high. So here we are going to declare variable sum, and this is where we are going to put our answer. So we make sure there's nothing inside. We initialize it to 0. We are starting the counter from 0.01 because we are adding values from 0.01 to 1. Only 2 decimal places. And we say that why the I counter is less than or equal to 1.0 because we have to go up to 1.0. So we have to include equal. We are going to sum equal to sum plus I. And when we write sum plus equal I, means the previous sum value, we are going to add it to I, then we get a new sum value. We increment the counter by 0.01 because 2 decimal places at a time. So after we finish, we display our final results. Again, this program will work. There's no any error. The error here will be logic error, which means the program grammatically is correct, but the answer may not be correct due to decimal places. So let's start the animation. We initialize our sum variable, make sure there's nothing to 0. Then we check our condition, which is true, because I is 0.01. So we're going to check if 0.01 is less than or equal to 1.0. It's true. So if it's true, then we're going to add 0.01 to the value of sum, which is 0. Now the question here is which line will be executed after this line? And of course, it will be line 7. So let's write 7, and that is correct. So I click OK. So line 7, the sum will be 0.01 now. Then we increment by 0.01. So our new counter will be 0.02. So that's I is 0.0. Is 0.02 less than or equal to 10? Yes, if that is the case, then we are going to add 0.02 to 0.01. Remember, the sum is 0.01 now. I is 0.02. So the same line 7 will execute. So our new value will be 0.03. Then we increment by 1, so our new I will be 0.03. We check the condition is true, 0.03 is less than or equal to 1.0. Okay, if that is the case, then we're going to get 0.03 plus 0.03, which will give us 0.07. And that will be line 7 execute, and we get 0.06, line 7. Then we increment by 1, so now our I will be 0.04. 0.04 less than or equal to 1.0? Yes, then we should add it. So we get 0.1 or 0.06 plus 0.04. That will give us 0.1. Then we increment the counter by 0.01. So that will give us 0.05 now. So condition is true, we had again, line 7. And then increment by 1. Condition is true, we had again, line 7. Condition is true, we had again, line 7. So that will give us 0.28. We increment by 1, we get 0.08. We're almost done. We had 0.08 to 0.28 because the condition will be true again. And that will give us 0.36. We increment the counter by 1. We're almost done. The condition is true again, so we are going to add it. So that will give us 0.45. Okay, so we increment by 1. This is where our program starts now. You see that we are changing to decimal. Instead of from 0.09, it should give us 0.1. It's giving us 0.099. So guess what will happen? The loop continue condition testing until it's very difficult to reach 1 because of the precision. Again, this program syntax, the grammar of Python is correct, but the precision of the value will determine. So determined by the variable data type, the precision should be many. So here they say 1 I is less than or equal to 1 is true. The loop will keep executing. And line 7 again. And again, we keep going, and we may reach there, but it will take a while. So I'm going to stop somewhere here. And we keep going, adding 1. Let's try one more time, see what will happen. Now we are 0.119, and again, the decimal places will keep increasing. So let's continue with the slides. So the advice given here is that we should always use the whole number for the loop counter variable. Never use a decimal number because of the precisions. Now let's see one program here, how to find the greatest common divisor. This is an algebra problem. For example, if I have 2 values, 4 and 2, the greatest common divisor will be 2 because 2 is the highest value that will divide by 2, and 4 divided by 2, both of them, and the remainder will be 0. I can use 1, but 1 is not greatest. 1 needs to be lowest. Like for example, 16 and 24, I can use 2 because 2 is the even number and then both numbers, but 2 is not the greatest common divisor among the 2. The greatest will be, I take 16. 16 divided by 16 is okay, but 24 divided by 16, the remainder is not 0. Then I'll use 8. 16 divided by 8, the remainder is 0. 24 divided by 8, the remainder is 0. So the greatest common divisor for 16 and 24 will be 8. So let's see how we're going to implement the program. Now, in our program, we are going to use a variable named k. So here we say, you know, the number 1 is a common divisor, but it may not be the greatest common divisor. So we're going to check from 2. What again, when I'm solving this problem, I look 16 and 24. As a human being, I know odd number will not work because both numbers are even numbers. And I can just tell straight that, okay, I'll start from 4 or 8 or 16. 16 doesn't work for 24, so 8. But computer doesn't know this. So computer will start, even is even two even numbers, it will stay check with 3, 5, 7 until it get the number that is right. So we are going to, again, we will see let's go back and see the code, which is a very short code. So here we ask the user to enter two input values. Now we are going to check if the two input values, what number will be a greatest common divisor among the two. So if, for example, if I have 8 and 16, then 8 is the correct answer. If I have 2 and 4, then 2. If I have 1 and 3, then it's 1. If I have 9 and 6, then it's 3. So what we did first is that always the greatest common divisor can be 1. Any value you can take, 1 can divide any value. So we initialize this program from 1, the GCD variable from 1. As we said, computer will start from beginning. Now with K, we don't want to start from 1. Why? I can start from 1, which will be correct. But we know that 1 always is not the greatest common divisor. It's not always. So say we start from 2. So here now we say that, but if I start from 2, I will make sure that the two values shouldn't be 1. Or at least 1 shouldn't be 1. But the best way shouldn't, because if I have two values, 1, 1, what is the greatest common divisor? It's 1. It cannot be 2 because 2 give me decimal answer. So that's why we have a condition here saying that if we start the divisor from 2 and the GCD from 1, we said why the K is less than or equal to 91. Yeah, sorry, N1. That's the first value, N1. Remember, K is the divisor, so it shouldn't be bigger than the number. So at least it should be the same, the highest. Then K also for number 2 should be less than or equal to N2. Now, the condition here said that if N1 modulus K equal to 0, that's what we are looking for. We say a common divisor means if you divide that divisor by the two values, the remainder should be 0. So we are checking the condition. We divide the first value by the K is 0. The second value by the K is 0. Then that K value should be the greatest common divisor. If I start from 2 and the condition here is false, then I'll move to increment by 1. So I'll move to 3, I'll move to 4. This is a while loop until if this condition become false, then again we stop. So when we get the answer, we are coming to print the greatest common divisor for N1 and N2 is whatever value we get for the GCD. So we have another program to predict a future tuition using a loop also. So let's see that program. So here also we are using while loop. For example, we know the tuition for this year is 10,000. But we know that the tuition will be increased every year by 7%. So here we say why the tuition, we don't want to go more than 20,000. So we say why the tuition is less than 20,000. We multiply the tuition by 1.07, then we increment the year by 1. So the tuition will be double in what year? The goal of this program is again to find when the tuition will be double the year. So tuition is 10,000, the year 0. We go up to 20,000, less than 20,000. Because we want double, only double. Every year we increase it by 7%. So it will be 1.07 times the tuition amount. And here we are assuming that every year is increased constantly 7%. So from this we can know when it will be double. And let's try the program and see. So our initial tuition was 10,000. Then we check why the tuition is less than 20,000. we multiply by 1.07. So when we are checking the condition, what will execute? The line 5 will execute. And then that will give us 10,700. Then we increment the year by 1. And we go back and check. The condition is true. 10,700 is less than 20,000. So our line 5 again. And this time we multiply the 10,700 by 1.07. So that gives us 11,449. We increment the year by 2 again. We check the condition with 11,449 less than 20,000. Yes. So we execute the same line again, 5. And we get 12,215. We check the condition again after we increment the year by 1. And the condition is true again. So line 5. Our new answer is 13,107.96. We increment the year by 1. We have 4 years now. We check the condition first. 13,107.96 less than 20,000. Yes. So we multiply it by 1.07 again. And that gives us 14,025.51. We increment the year by 1. We check the condition is true. We multiply by 1.7 again. We increment by 1 year more. We are in 6 years now. We check the condition again. It's true. We multiply by 1.07. We increment the year by 1. Check condition is true. 16,057 is less than 20,000. True. We increment the year by 1. Then we check condition again is true. We execute the same line again. We increment by 1, so we are 9 years now. We check the condition is true. We execute again. We increment by 1. We check the condition again and it's true. So we increment by 1 again. So here we are going to stop. First we increment by 1. Then we check the condition. Condition is false now. So the line that will execute will be 8. We come out of the for loop, and that is correct. So we print that it takes 11 years. The tuition will be double in 11 years. And then we print the format, the amount it to be. In this case, it will be $21,048.47 in 11 years. So predicting the future tuition, we can see that we start from 0. It was 10,000. Then we increment by 1 year. We multiply by 7%, 1.07. 2 years, the same thing until we reach the final answer. We can also write a program using the loop to convert decimal numbers to hexadecimal. So let's see this program also. So first we ask the user to enter the decimal value. So we use the input function and the instruction enter decimal integer. And always we remember when we use input function, the data type of the value will be string, and we can't use it in arithmetic operations. So we convert it to a whole number, which is integer. Now we want to convert the decimal value that we enter to hexadecimal. Hexadecimal have base 16. So this is a very tricky. We said that, okay, why the value we enter is not equal to 0. If it's equal to 0, we don't need to find hexadecimal. It's the same value. So why it's not equal to 0, that will be our sentinel value. We first of all, to find hexadecimal value from decimal, remember we divide by 16, then we keep the remainder. So the remainder is what we want. So we divide the decimal number by 16. The remainder we put it in ESA value. And now let's convert decimal to ESA. Now convert decimal value to ESA digit. When we get the hexadecimal value, we make sure if the value is between 0 to 9, which means it's the same value. Remember, hexadecimal value from 0 to 9 is the same as decimal number 0 to 9. But since hexadecimal values are 16 digits, A will be 10, B will be 11, up to F, which is 15, 0 to 15, 16 digits. So we check the first condition. If it's a value between 0 to 9, then it's the same. So we say the char S value plus odd. Else, we say the hexadecimal value minus 10 plus odd A. Then the S char plus the X, we give it to the S. Then we do our division 16, divide by 16. Again, the base is 16. So this will give us the answer in hexadecimal. The S variable will give us the answer, which we print the S number is. So let's see how this program runs. So here we need to enter any value. Let's say I'm going to enter 56. So the hexadecimal value is 56. Now the statement create an empty string for us. We start with. Then we check, is 16 not equal to 0? So the loop continuation condition decimal not equal to is tested. It is true in this base, so the loop will execute now. So first we divide the 56 by 16, the remainder is 8. Then secondly, here they say what will be the S digit after this statement executed. So we have converted again the S digit, which will be convert hexadecimal value to S digit. So we said if the value is between 0 to 9, we should have that value. So the S value was 8. The S value minus 10 plus odd A. So since we have 8, now they say what will be the S digit value. Then since it's between, the first condition is true, between 0 to 9. So we get the char S value plus the odd again. So we put the answer here is 8. So you are correct. The reason why, because we said if the value is between 0 to 9, it's the same digit. In hexadecimal, start from 0 to 9. But decimal will end at 9 because 10 digits. Hexadecimal is 16 digits. So we still have A to F, which is we have another 16 digits more. A is 10, 11, 12. So if we should have 10 here, then it will execute B for us. Or in this case, it's 8, so it's execute the same 8. Okay, so the S char will be 8 because, again, the first condition works. Now we say the string S is updated by concatenating the S digit with S. So the S digit and the S char plus S, which is the S digit. And this will be 3. Then we check the condition again. Is the decimal not equal to 0? Yes. So if it's not equal to 0, then we have to start second run. Now we have 3. What will the digit be? It will be the same 3 because it's from 0 to 3. 3. Say you are correct. So it's 3. Then the string S is updated by concatenating the S digit with S. Remember, we have 8 before, now we have 3. And so we join the 2 together. When we divide decimal by the 3 by 6, we get 0. So this will make this condition to stop. So when this condition stops, the answer will display 3 and 8. Remember, first we get 8, the second we get 3. So we join the 2 together. That's what we are doing here, to join the 2 together. Until the decimal value becomes 0, then we can't divide no more. Then we stop. So the correct answer for the result will be 38. So we can see 3 is in the 0 position, the second digit, 8. So that will be the conclusion for, one more, sorry. So also we can use break and continue, as we said earlier. For example, using the break and continue keyword, let's see an example. As we said earlier, break will stop the loop. Continue will skip the condition. So here I want to add some values, let's say from 0 to 19. So we declare our sum variable. The number we initialize to 0. The number variable will be our counter variable. So while 0 is less than 20, we add 1 to it. Then we sum the 2 together. But we have a condition here saying that if the sum is greater than or equal to 100, we break. Which means if we keep adding the values and we reach 100, we will stop the loop. So we don't care about the number less than 20. Unless if number less than 20 condition is met first, it was false, then the break will not work. It will stop before the break. But if the number is keep increasing from 0, we reach 17, and the answer became more than 100, then we are not going to go to 18, 19 or more. We break from the loop and print our result. So let's see how this loop works. So first, we are starting from 0. 0 less than 20, yes. If that is the case, then let's add 1 to the number. Then we add it to the sum also. Sum will be 1 also. Is 1 greater than or equal to 0? No. Okay. Which is the sum is 1. If that is the case, we cannot break. We go back and then we increment by 1. The condition is true. We sum. We get 3. Is 3 greater than or equal to 100? No. So then the condition is keep working. So we go back. And of course, we have 2. Is 2 less than 20 years, so we can still work. Increment, add it. Condition is true. We keep going. Here, the sum greater than no is false, so we go back to condition. Condition is true. We had 1. We had a sum. Is 15 greater than or equal to 100? No. So we can't use the break yet. We keep adding. Still, we cannot use the break. No, 28 is greater than or equal to 100. No. So go back. Now we are checking with 36. No. So we go back. Now we are checking 45 greater than or equal to 0. No. So we go back to the loop. No, we go back to the loop again. This time it will be 11. 11 plus 55, 66. No. Go back to the loop. 12 this time. 12 plus 66, 78. 78 greater than or equal to 100. No. So we're still in the loop. This time we have 91. Is 91 greater than or equal to 100? No. So we're still in the loop. So we increment 14 now. It seems like we're going to get out of the loop. Now we have 105. Is 105 less greater than or equal to yes? So this means the loop we have number is less than 20, but we can't go more than 14 because the next value sum here is more than 100. So the break will break out of the loop. Now they say which line will be executed after this statement. Again, the condition is true, break execute. So line 10 will be executing now. So we come out of the loop, which is correct. So that's our final answer. Same thing, we can do the steps all over again. I don't want to repeat it. So let's go to the next program to test the continue. So continue also is the same concept, the same program, but this time we are using continue. And now I want us to see the difference. You see that the continue, we will still go up to 19. The only thing is that when the condition sum is greater than or equal to 100, actually this is still the break. Let's see if we have the continue code. It should be continue. Press here, but it's giving me break. Okay. Maybe let's try and close this program. This is break also. Yeah. Which we can see the continue function. Let's see. Okay. Again, by mistake, both programs use continue. And I know I can change this. Again, this is iCrowd. So again, the whole concept of continue is that it's going to skip the condition if the condition here is true. So it's not going, it will still run, but it's not going to sum it no more. So this is how the break works. We say when the condition becomes false, we come out of the loop. But look how continue is. We jump to the end of the iteration. So when the condition is true, actually this is the continue method. So for example, we are doing the same sum from 0 to 19. We increment. But now we have a condition that if our number is 10 or the number is 11, we continue, which means we are not going to add 10 and 11 into the sum. Then we're going to add the numbers from 0 to 19, but 10 and 11 will not be added. So again, that will be the end of this lecture slides. We have some few coding. Again, we shall go through this code later on in the classroom.